We are going to continue, but before we move on to the next page, I just want to go over the rules here. So we are going to start using or thinking about algebra tiles to model expressions. I'm not actually going to get them out, but you could if you wanted to at a different time. But basically, if you had tiles, you'd need to think that or know that each rectangle tile represents the variable x. So one rectangle tile equals x, okay? And each small tile, square tile, represents 1. So if I had 3 of these, three rectangle tiles and 2 square tiles, it would look like this. 3x, so 3 times x. Remember, we don't need the multiplication symbols anymore. If you have a number times a variable, you just put them together. Plus 2. So we would have 3x plus 2 is what that would look like. So let's try this. 3x minus x is equivalent to 3. Is this correct? Right, it's not. Because if you have 3 x's and you take 1 x away, you're left with 2x. That would be your answer, okay? Going back to the page then, we're on journal page 184. We're going to use algebra tiles, just the idea of them, but you could use them physically if you could, to model expressions. So write the expression that the model represents. So we're just going to write down what this means and just pause it as we go. Okay, so the answer would be 4x, so 4 of these times or of them, plus 3. That's how you write it. Number 5 would be 5 plus x, if you keep it in the same order. Number 6 would be 3x plus 3. Use your tiles to model each expression. So draw the tiles, okay? So draw tiles to model. Make a quick drawing. So here you have x plus 6, so you can just draw a single line to represent a rectangle tile, and then 6 small square tiles for those 6 singles. So that would be x plus 6. Number 8, 4 x's plus, oops, I don't even need that, just a small square tile. Sorry, I didn't teach elementary age kids, the little ones, so these tiles are new to me. Number 9, 3 plus 2x. So we're going to think 1, 2, 3, and 2 of those. Number 10, make a quick drawing of algebra tiles to help you explain why 5x minus x is not equivalent to 5. Well, we already went over that when I gave you the little demonstration. Remember this one? If you take an x away, you're taking an entire rectangle tile away. So you could draw it like this. 1, 2, 3, 4, 5. And take away 1. And describe it. 5x minus x is the same as 5x minus 1x. If you start with 5x tiles and take 1 away, you're left with 4. So 5x, so if you start with 5 X unknown amount, right? Value tiles, 5X tiles. And take one away, one X tile away, you were left with 4X tiles, not 5. Here's another one. Make a quick drawing of algebra tiles to help you explain why 3x plus 3 is not equivalent to 6x. So here's your answer. 3x and 1, 2, 3. Well, I don't see 6 rectangle tiles. I see 3 and 3 single ones. So the x tiles and the 1 tiles are different shapes. You can't combine them to get 6x tiles. You can't combine them to get 6x tiles.